Jim Gentile. I'm going to wear two hats. All right. My former hat of about 3 months ago, I've been the president of Research Corporation for the last 9 years, and now I'm a dean again. So I know how to ask and partially know how to give. But I think that becomes a value added, at least in a lot of ways, because the first thing I want to say is know the people and the organization to whom you're going to go for resources. Do your homework. It's very important. Make sure you know the programs they have, the programs they have not, and the history of the funding there. Now, I will say something that I believe sincerely in. Funding is only secondary to many things that go into convergence. Unless we have our faculty relationships in order, unless we have our institutional bylaws and relationships geared to be able to form teams, all the money in the world will not sustain convergence on a campus. And that becomes very, very important, I think, in then seeking the resources. What I heard throughout this meeting, and it's just wonderful how much philanthropy there is. Philanthropy from individual donors, philanthropy from industry to help really fire up and catalyze convergent opportunities. And I think that we have to take advantage of that. And in many ways, the group that we're looking up here now is then that second wave of funding that comes in behind the philanthropic thrust that's out there to help move things forward. Funding can respond to needs and ideas. Funders can oftentimes, and I include individual donors who would come in, can sometimes stimulate those ideas. But ultimately, the cultivation of the ideas will have to go for a sustaining type of fund or an initial type of funding mechanism through an organization, either a private organization or a public organization. There are many different types of organizations that can come in and help to stimulate those ideas from the outside. I'll give one example. Research Corporation, where I was. We started an initiative we called Dialogue. And what Dialogue is an integration of science and dialogue to foster and catalyze cross-cutting research and the conversation of such. I won't go through the details of it, but basically we issued a challenge. Faculty applied for that challenge, and they had to apply as teams. That was mandatory, and they had to describe why every member of the team was listed. That was very important. Then they had to come to a meeting as a team, and all the teams came to the meeting because the challenge was a uniform challenge. Nanotechnology-driven artificial photosynthesis in that particular challenge. So they all had something in common. What we did not do was take them to the National Academy, however, as we could have. Instead, we took them to Biosphere 2. And if you haven't been to Biosphere 2, it's really quite elegant right now. It's where you can stay, not inside the Biosphere, by the way. The Columbia University had put up some very nice apartments, casitas, that one can use and stay there. But I wanted people to talk to one another. I wanted them to interact with one another. I wanted to surround them with rattlesnakes and javelina so that they couldn't go into the bar with their friends at night or the nice hotels. We stacked up with beer and coffee and various times. And we catalyzed the opportunity for groups to form collaborations with one another by giving catalytic grants that could be received with a 3-page proposal at the end of that conference. Well, this has been going on for about 5 years, and all I can say is that the research is moving forward quickly. Somebody yesterday showed a thing where connections, like a neural network, were there. We've done that same tracking. The neural network forms. And the successful teams are those that have gone back to a campus that can accommodate the fact that team success is important and all members of the teams are moving forward. So we go back to the environment. We're going to hear today from colleagues that are from the federal sector. We have a colleague from the Keck Foundation. In the audience, I know we have colleagues from the Kavli Foundation, Howard Hughes, and an important colleague from Science Foundation Arizona, which represents the public-private interface using state funding. We're going to just have short presentations because my sense is there's going to be a lot of questions, and a little summary of perspectives. And then we're going to open it up as a panel so the questions can be directed to an individual panelist, or you can toss a jump ball out there. And even though I'm short, I'll be the referee. So with that, we'll go from left to right. And John.
Thank you, James. I'm John Lorsch from the National Institute of General Medical Sciences. I wanted to first thank the organizers for this very interesting meeting. I really enjoyed the last day and a half. I want to start with two premises that have been guiding my thinking in my first month, which is all I've been at NIGMS so far. The first is that I don't know where the next big breakthrough, or even any breakthroughs in science, are going to come from, which is another way of saying that really what I'm committed to is investigator-initiated, question-driven fundamental research. And we've been having quite a lot of discussion recently at NIGMS as a run-up to our new strategic planning process about how we can renew and reinvigorate our commitment to investigator-initiated research. The second is about mathematics, which we've heard a little bit about here already in the last day and a half, which is that in order to start anything new right now in the current environment we're working in, we need to end something, or at least substantially reduce something that's ongoing. So that's the reality on the ground. So as we think about what you think we should do, bear that in mind. So just very briefly, what does NIGMS do right now to promote interdisciplinary or interfacial science and convergence? Just a few examples. So you've heard about the Centers in Systems Biology from several people here. We also have computational biology centers and biotechnology development centers that we fund. Now note, all of those three things have the word centers in them. You've heard a lot about centers already over the last day and a half. And so I'll just toss out a question, which is, are centers the only way to promote convergent science? Are they the best way to promote convergent science? That's something that I think would be interesting to discuss in the next hour. We, of course, are also heavily invested in training, and much of the training we promote is at interfacial regions of science. For instance, training programs in systems biology, computational biology, the chemistry-biology interface, biotechnology, et cetera. Now, those, I think, are obviously, given their names, as I said, interfacial, interdisciplinary training programs. But I think it's interesting to note that in many ways what we're doing is subdividing science further by giving them these names. And so a question I would put out to you again, and that I think would be interesting to discuss, is this the right thing to do? Is it the right thing to do to promote convergence, to create new training areas in further and further subdivided fields, albeit ones that are interdisciplinary? So that's really all I wanted to say by way of priming the pump here. Mostly what I want to do is to hear your ideas, to hear what you think are the barriers and the obstacles to convergent science, and maybe what we could potentially do to help overcome those obstacles and barriers. So thank you.
Good morning. I'm Dinah Singer. I'm the director of the Division of Cancer Biology at the NCI. The division is one of the major funders of basic research in cancer. I actually came here with some prepared thoughts that I was going to share with you, and after listening to the discussion, I threw those away. And I'll try to address some of the comments that came up. But let me just tell you a little bit, excuse me, about what we do to promote convergence at the NCI. Cancer really is, or the study of cancer is a perfect field for promoting convergence, because to really understand cancer initiation, progression, metastases, you have to pull in a wide spectrum of sciences, both from the biological sciences. You still can't hear me? That's unusual. Okay. You have to pull in a lot of different fields across biology, across physical sciences, and across engineering. So historically, we have promoted what's now being called convergent science. As funders, we don't just fund. I think all of us at NIH also feel it's part of our responsibility to anticipate needs, by being able to look across the portfolio of our, the landscape of our portfolio, to see emerging areas and then to respond to that and try to promote it. So we've done that at a variety of different levels in terms of funding, supplementing grants to bring in new approaches. We have a program for collaborative research, collaborative R01s, which require people from different fields, from biology and physics, biology and computational sciences, to work together. We have large programs that establish centers, but incorporated into that is a training program to try to sustain the convergence of the fields to actually create a new field. And so we see this as an iterative process. You create a new field by bringing in people, teaching them across disciplines, and then they need to go out and establish this new field. And that, in fact, I think is one of the challenges that we need to talk about, how people who are now trained in a convergent field, the new investigators, can actually sustain that field in terms of funding, but also support from their institutions. And so that raises the question of, how do young investigators, or even established investigators, get credit when they're working across disciplines? We've tried to address that in a couple of ways. The most recent one is that NCI is undertaking an experiment in revising what we ask for in the BioSketch. Rather than asking for a list of publications, we're asking all of our applicants to summarize their major contributions, 5 major contributions that they've made in science, that allows us then to evaluate what their contribution was rather than where they were on the publication listing. There was a discussion earlier today about how do you continue to support the infrastructure once it's established. How do you have the staff who will maintain and hopefully move forward the infrastructure as the field develops. So we're right now talking about creating a new funding mechanism specifically for that. So you don't have what we can call staff scientists who are derivative of a PI but who can generate their own funds. So that's a work in progress, but it's something that we hope will come out fairly soon. DEA is the Division of Extramural Activities of NCI. One of its major challenges is to assemble interdisciplinary, transdisciplinary review. That we've recognized as a major problem in trying to evaluate applications to many of the programs that are addressing convergent issues. And so we really work very hard with that review organization to assemble study sections that really can be transdisciplinary. The one last thought that I'll leave with you in terms of approaches, and I don't think it's been discussed previously, is some efforts that we're making now to try to expand our reach, if you will, to try to use crowdsourcing to bring in new people into the field and citizen science to try to address the issue that we want really to broaden our horizon beyond the sort of classical strict sciences to perhaps other areas that haven't traditionally been brought into it in terms of behavioral sciences, but also just other areas in the arts that haven't been brought in before. So hopefully some questions that I can address later.
My name is Joann Roskoski. I'm from the National Science Foundation, and I'm standing for two reasons. First, because I sat in the back of the room for all of yesterday and could never see who was actually speaking on this panel, so here I am. Secondly, this way I'm a bigger target, right? So, try so hard to hit me. I want to thank the organizers, I think, for inviting me to this very exciting workshop. Just a little bit of background. I've been at NSF for 24 years, and I started out as a program officer, and now I'm a deputy assistant director. So I've sort of gone up the ranks in NSF and been involved in a lot of the evolution of NSF over those years. A couple of statistics to wow you with, or at least inform you with. If you look on the NSF website, there are 74 solicitations that are listed under the Biological Sciences Directorate. Of those, 22 are multidisciplinary, meaning they involve other directorates within the foundation: social sciences, geosciences, engineering, math, and physical sciences. So about a third of the solicitations are multidisciplinary. These are largely for core programs, but also special solicitations. So one of my questions to you is, how much is enough, right? That's always the question, how much is enough? So about a third of our solicitations are by design multidisciplinary, and 6 of them involve collaborations with other agencies, okay? So we heard some questions about agencies working together. So 6 of our, or 10% of our solicitations are not only multidisciplinary within NSF, but also multi-agency, and those involve 9 other federal agencies. So it's not just NIH, which would be a logical partner, but NIST, EPA, USGS, DOE, and so there's certainly a great interest in seeking partnerships with interested other federal agencies. Within the core programs at NSF, which are the traditional programs that you think of, like ecology or biophysics or biochemistry, if you look at the funding profile over the last 5 years, on the average, 19% of all our awards were co-funded with some unit outside of biology. So that's 20% of our projects are co-funded. That's the best sign of real interest in other disciplines. If you go to a program officer in physics and say, how would you like to co-fund this project, and they take some of their limited and valuable resources and put it on your project that you bring to them. So again, 20%, how much is enough, right? We agonize over these questions all the time. So those are the core programs. We make about 900 awards a year in biology, so about 20% are obtain resources from other parts of NSF. Now there's a quid pro quo. It means that biology also funds projects that come in from other parts of NSF to us. So we've looked over time, and it's kind of a wash, It's not like we double our resources by bringing resources from other parts of NSF. We also donate resources or give resources to projects from elsewhere. So that's the core programs. That's where most of our budget is located. But I wanted to highlight 4 things that I think are particularly germane to the idea of convergence. So I would argue that's homegrown convergence. That's individual PIs saying, I have a project, and I want to involve a physicist or a mathematician or an engineer or a couple of those people. It just comes in under our unsolicited, proposals. So you don't hear about those programs in general, what they're doing. What tends to get a lot of press are the higher visibility programs like Inspire and Biomaps, and I'm going to say a little bit about Ideas Labs, and then IGERT. Let me mention IGERT first because we talked about training and education. I think a lot of people in the audience are familiar with IGERT program, which is by design set up to enable convergent training, right? Training of individuals that want to work on multidisciplinary problems. And I'm not going to go into more details. You can go to our website and find out all about it. I want to say something about Biomaps. This is the interaction, an explicit interaction between biology, math, the physical sciences, and engineering. This started about 4 years ago. Kamal Shukla is the bio-program officer that works on a team with someone from engineering and MPS to enable that program, and it explicitly focuses on bringing teams of individuals from the math, physical sciences, engineering, biology together to do research. And so I'll just read you the title of one of the things they've funded: Experimental Computational Studies of Microtubule Dynamics and Regulation by Binding Proteins, right? And so you can ask Kamal what it's all about, right? Because I'm a microbial ecologist. The other program you've probably heard about is INSPIRE. This was actually inspired by our last director, Subra Suresh. And his idea was that NSF was too conservative in what we were supporting. There were too many hoops to jump through, and he wanted to open up the creativity of the scientific community. So he encouraged people to send in proposals that were multidisciplinary, trans, inter, however you want to design it or define it, to a program officer and say, I have this idea for an INSPIRE. These were not peer reviewed. These went to a program officer, and if the initial program officer said, hey, this looks really interesting, then the other program officers for the other disciplines would also have a look at it, and if all of them agreed, this is cool, let's go with this, then it was funded, right? So it's followed on a model we have already at NSF used to be called SUGAR, Small Grants for Exploratory Research, and then now they're called RAPIDS and EAGER, where you don't have to go through the peer review process. Needless to say, there was a huge influx of inquiries, like 2,000 inquiries, because there's no lack of creativity out there in the scientific community. You've got lots of it. It's just a question of how that creativity gets translated into a proposal, and then what are the resources that are available to fund it. I'm going to sit down. I'm taking too long already. We were asked to talk about challenges. I think really the only challenges we have are lack of funds and the receptivity of the scientific community to think outside their comfort zone.
Good morning. I'm Maria Pellegrini. I'm the Executive Director of Programs for the WM Keck Foundation. And I just want to start by saying thank you to the private funders of this workshop, whose names you will see out on the poster. I know that the National Academy itself, of course, is a private nonprofit organization, and I was very gratified to hear throughout yesterday's presentations of both the foundation and the individual philanthropists who have been funding convergent research. So we have a place. Our resources, even combined, are much, much smaller than those available from federal sources and state sources as well, as we heard yesterday. So the struggle that all of the private foundations have is how to make a difference when your money is so small. And so what we try to do, I would say, as a group, is be flexible, be nimble, and go where the money isn't, so that even our small dollars can make a difference. That's the one thing. We can be nimble, flexible, hopefully just in time in many cases. And also, we, as a group, do things in many, many different ways, as Jim Gentile alluded to earlier. There's a saying among fundraisers and universities that if you know one foundation, you indeed know one foundation. So some foundations give endowments to sustain programs, hopefully over extended decades and beyond. Others fund individuals. HHMI is particularly well known for that, although they do other things as well. Foundations like Gordon and Betty Moore and the Keck Foundation, we fund specific projects. The nice thing about, I'd say, all of us is that we're able to take risks. And we don't have to report to Congress, thank goodness. And so that gives us, again, a flexibility and an ability to do things that may not have proof of principle, may have no preliminary results yet, and to be able to do that and also be willing to fail. Keck underwent an evaluation of some of our programs in 2010, and I'm happy to say that several very, very distinguished panelists told us in a very nice way that we had many noble failures. And they said, and they also told us, don't stop. Be sure that you take those risks, because sometimes nature just doesn't work like that, or the leadership just has failed in some way. It's still worth taking the risk. That's just really important. And I know that that's much harder for my other colleagues here. The other thing is that they told us that even in our failures, they often found that there had been collateral benefits. And now we look very hard at projects that are high risk and say, well, even if it fails, will there be collateral benefits? So I just offer those two things as a thank you to the panelists who told them to us and offer them up as food for thought in funding in the future. One of the things that I heard consistently yesterday was, I have a problem to solve. This is not a hypothesis I want to test or something I'm curious about. I've got a problem. Now, frankly, I think usually that problem is based on something you're curious about and you can't find the answer because you don't have the tools. So I think that in convergent science especially, it's clear that we need to be focusing on funding new instruments, new technologies, new methods. And that is something I think that again, private philanthropy can be a big help with. And I'll stop there. Thank you.
They're not so bad, are they? Right? Let me open the floor for questions.
Question you had for us, whether centers are the way to go for health or for convergence. And I have to say that if you don't have the infrastructure required, it's very difficult to happen. So we can have a seed program that they get the people talking. And so if you have, we have learned here what is successful. If you make a center which has very clear goals and has all the components that are needed, flat transparency, all that, I think they can be very successful. And there are some great examples. In NSF, they had this MERSIC, for example. And people have criticized because it's, you have to have a basic of research to access these money in centers. But on the other hand, they have created new programs that are, very outside the box and have helped to move, like MERSIC Northwestern. We just did some science of the arts with the Artists of Chicago, and it's now became funded elsewhere, but we still use the infrastructure from the facilities that the MERSIC provides, and it's able to pay for some of these technicians you might need and so on. So there are models where this can work, and I think that, I do encourage that they develop more, and maybe inter-schools that we're talking about to move fast.
I was just going to say that I think there are different ways to define centers. There's centers as physical space, centers as core facilities, centers as funding models. And so maybe it's worthwhile differentiating some of those things. I was mostly asking about the latter. Is a center as a funding model the only way to promote convergence? But I think it's worth thinking to some extent about the former as well. Can one get convergence and interdisciplinary research without having to build a new building, for example, which anyone who follows the New York Times saw a series of articles about the over-leveraging of American universities in terms of building programs. So if every time we want to start a new initiative, we have to build a new building, I think we have a problem.
So I'm going to echo what John said, that we have to enter into the development of centers carefully, but I think as a way to seed a new field where you want to bring people together, it's a critical way to really nucleate the field, but it's not sufficient. I think it's a starting point. So when we have centers, we also complement that with grant mechanisms that allow people who weren't funded through the centers to actually collaborate with the centers, with people in the centers, and hopefully as a way to sort of propagate that out into the broader research community.
I'm Nicholas Peppers from the University of Texas at Austin. When I accepted to be in this committee of invitation from Joe DeSimone, I did it because I believe in convergence. There are major diseases that solutions need to be given. There are people dying every day as we sit here talking about whether our research is going to be supported by NSF or NIH or the Keck Foundation. Maybe I'm a little bit altruistic or maybe too old, but I believe we need to do something for those diseases. That's why I liked yesterday what I heard about HIV, the HIV initiative, the tremendous philanthropists that really believe in it. That's why I praised in public Anna Barker and Larry Nagahara, not because they supported me, but because the NCI or PSOC program has done magnificent things for cancer. One of the first things that happened to me when Joe asked me to be in the committee, I thought of IGERT. I mean, that was the original idea of IGERT. I was in the 1998 cohort. We ran it for 10 years. IGERT was the idea we're going to bring everybody to work together, destroy all academic barriers and so on, and do that. And of course, I'm directing my question to you, Dr. Roskoski. IGERT worked, but it became a bureaucratic exercise. It's a www.igert.org that sends you reports every month, and you have to balance this and that, and the number of students has dropped from 12 to 10 to 8, and we don't support them as well, and we don't control what's happening. And you know what the worst thing is? Many of these programs finish after 10 years, and contrary to what NSF had said, they have to become important independent programs and be absorbed in the university structure. They have disappeared. So it was a nice way for many universities to support their students. And this year, you are not even advertising an IGERT. I'm not accusing NSF. You've done marvelous work. This is the name of the game. But all I wanted to say is, meanwhile, there are huge problems out there. So for me, what you're doing, all four of you and your organizations, is wonderful. And we accept it. But for me, the problem is much larger than just having a center of 10 of us, working together and supporting one graduate student. We really need to find solutions to major medical problems. And I hope the next panel will address that more vividly with Susan and Joe. And how do we find those solutions? Not with an additional $100,000 or an additional $50,000. It's a question, it's a comment. It's pretty good.
Thank
let me just say something about the IGERT. So yes, IGERT has disappeared, and largely for the reasons that you mentioned. So, all programs start with sort of lofty goals and noble ideals and vision. And IGERT ran for about 15 years, and over time, there's a kind of, how do you want to say it? The early visionaries, they move on, they retire, 15 years is a long time in federal government, anything. And so there have been a number of evaluations that said, what happened to the program? The original vision and goals have they been met now? Is, in fact, our institutions, our universities, supporting multidisciplinary, transdisciplinary training? Do we still need an IGERT program? It was ahead of its time when we got started, which is good. We like to think we do those kinds of things. But we also think if it's a good idea, maybe over time, then it goes viral, right? It goes viral. It's not clear it's gone viral. It's much harder, as we've noted over the last day and a half, to change academic institutions. And so we pulled the solicitation, and there's a a group at NSF that is looking at the need for multidisciplinary, interdisciplinary training. Does it still exist? What kind of training is needed? And then what kind of programs could NSF propose, put out there that will fill those needs. As part of it's a year-long process. As part of this process, we're going out to the community, asking for their ideas, because we always use the community first as a lot of times is where we get our ideas from, and then how we help to refine what they look like. So I'd say stay tuned. There's been some sort of heavy discussion about going to a more training grant kind of mode, like NIH has a lot of training grants, because there you can sustain a new area of science for a long period of time. IGERs for 5 years, and then you're out. And so there's a lot of discussions going on. I'd say if you have the opportunity to be involved and get feedback on what you think the next generation training grant should look like, please do so. But yes, IGERT had all the problems you discussed, and I leave it to my colleagues to talk about disease.
One more on this question.
Just a quick comment that I think in response to your concern about whether we're doing anything as part of the solution to health, whether it's cancer or any other disease. Certainly those of us who are involved in these convergent science programs, and I think certainly NCI as a whole, passionately think that that's part of the solution, that in order to really move forward for new approaches and new therapies, we have to do this. You look at genomics. You mentioned the PSOCs. We have our integrative cancer biology program. All of those have moved forward the application of therapy. So I think it's part of the solution.
One of the things that we talked about as a committee coming in, matter of fact, over the phone many, many times, and I appreciate the enthusiasm, that this is not going to be a National Academy's book that will become a doorstop somewhere, but it'll have an action plan with it. And I would hope that that action plan tends to underscore the need you need to hear about the value added of convergence for solving a lot of the problems that Nicholas was referring to, and the training that we need in moving forward. And so it's wonderful that you're here to hear it firsthand, and my hopes and expectations are that our report will emphasize that. We're going to go to the right, the middle, and the left. That sounds political, but I'm sorry.
Hi. I love that all these mechanisms are in place, and I've benefited from some of these large mechanisms. But I also have seen individual PI grants, smaller, grants that go on traditional tracks. Many of my grants as a chemist doing convergent research is, a third chemistry, a third biophysics, and then a third cell biology. And then, it becomes very difficult to get a good review, because I'm not doing enough chemistry for the chemists. I'm not doing enough cell biology for the cancer biologists. And so I'm wondering if there are any changes or any ideas about how to restructure the regular grant programs and bread and butter grants.
New kid on the block.
I think Dina mentioned earlier that there are, if one launches a RFA or a program announcement, there are ways to review in special study sections. So that's one way, at least in the short term, if there are particular areas we find to be high priority, we can deal with this problem. In terms of the regular study sections, it's a matter of, ideally it would be a matter of the questions you're asking. Are you studying gene expression? Are you studying cell dynamics? And those panels, the goal is to have them have the relevant expertise. It's up to the scientific community at some level to step up, right? So I don't want to throw it back to you entirely, because there are issues on both sides, and we're fully cognizant of that. But again, as was said earlier, I think if you want good reviews and appropriate expertise, you have to be willing to put a significant amount of effort into reviewing yourself. And as someone who spent 7 years on study sections, I can put my money where my mouth is there.
Young?
So
So my name is Liang Chen from the Kavli Foundation. I want to first mention two facts. First is that I think that it was previously mentioned that government funds versus private funds, where I think that when it comes to private funds in supporting basic science, it's so small. I mean, you combine every dollar given by private funding agencies in basic sciences, supposedly about $2 billion. Just imagine. NIH alone is over $30 billion. So I think that no matter what, we can never catch up with, I think, federal funding agencies. Here, I think that we must collaborate and make things possible. And I think that from a variety of different foundations, we're trying very hard now to work closely with federal funding agencies and try to understand what they are doing now. So then we can actually find our niches and then make things possible. I'll give a good example. I think that we talked a lot about center grants and so on. And it's understandable that they begin and they end at a certain time. And while private foundations like the Kavli Foundation cannot set up center with all the resources for 10, 20, 30 scientists, we can now then find a niche area where we can try to endow such center. So then it doesn't have to sunset, that it can have a momentum going until they reinvent themselves and then now become another center. So I think that there's a lot of possibilities of marriage, long-term marriage possibilities, if funding agencies between public and private can work together. And I think that these are the kinds of momentum that's really needed, especially now the funding is so scarce. I think all throughout federal, but also I think private funding agencies had gone through extremely difficult time during 2008 when the economic downturn came. All of us really had a big scare, and we were really, a lot of board members were wanting to have their money closer to their chest. And many of the science program officers like ourselves were lost in translation. And so I think that moving forward, it will be so essential that all the funding agencies should really communicate more and then work together. I think that the GRAIN initiative the President announced in April was a great example, that there were 3 federal funding agencies working together, but at the same time, multiple private funding agencies also gathered for that initiative. And that's a great example, and we should have more of those.
Yeah, I should add also that the private foundations are very, very likely to require a VIG from the institutions or the centers, a match. That there would be some way of partnering with the institution, which is probably a more common phenomenon of the private foundations. So if we were to give $75 million, we would expect $50 million coming from the base or something like that. And so always understand that the institutional partnership with a private foundation is usually a very deep one, as opposed to a transitional one, and that's why endowment monies often are given.
Just as a disclaimer, I'm okay with you pointing out that I'm on the left here. So
I would expect a lot of folks lining up on this side. But
so I want to make 2 points. One, I'd like to put an exclamation point on what Sharon and Ada were referring to regarding the peer review process. This is a challenge of the community. It's not on your shoulders alone, for sure. And the ideas of thinking through that and how we look at that to fairly evaluate the science that's being proposed, the science and engineering, I think we need to look carefully at that. And I know the cultures from the different agencies are very different, and I know more deeply about the challenges at NSF and thinking through when people don't even agree to review. And setting some norms out there that there's some expectation that the community needs to step up to the plate, and that's why we're talking about almost the resume fodder of people talking about at NIH. You're on a study section. There is a responsibility, there is a professional accolade there's an accountability, there's an openness, there's a whole lot of things to think through, and I know there are cultural issues, but I would just like to put it on the agenda of looking carefully at the peer review process. The second point I'd like to make is the center. We talked about centers. And those of us who have lived and breathed centers, we got Ruben Carbonell here, Matt Terrell, Nicholas, other people have been part of centers. Center management, these centers have really exuded the characteristics of convergence in a lot of important ways. And we talk a lot about the value add of a center over an individual grant. And some of those common characteristics we've been talking about for the last day and a half here, and some of the core facilities, the ability of convening people, and so, thinking through what it means to have a center, how centers are morphing, and in our lifetime, and becoming less and less easy to do. Those of us who were center directors, we thought it was our job to protect the PIs from the administrivia that we were getting hit with all the time. And it was important to allow people to convene and come together, but try to protect them from all the other stuff that was being sort of maybe from an accountability point of view. So again, I'd like to think through, what were those essential characteristics of centers that we all know and love, and try to maybe have the pendulum slide back to allow and foster the kinds of things that we've been talking about.
Any response?
I'd just like to make one comment about the reviewers and NSF. Actually, BIO's done a couple of experiments this year just because our success rate in the core programs was down to about 5%. And that just got to be that was ridiculous, right? I mean, it was either, giving everybody $25,000 or doing something radical. So we did a few radical things, and I won't go into, a lot of discussion about that. But what's happened because of the steps we've taken is, in fact, because we are not now reviewing 100 proposals to fund 5, we are getting a better response from the reviewing community, because they know NSF isn't going to be sending them 10 proposals to review, but 1, and they're sending reviews back. It's really interesting. Anyway, so we're doing a little sociological. We actually went to a proposal stage, in a 4-page pre-proposal, which is evaluated by a panel, and then a certain percentage of those, usually double what we know our funding, rate is going to be, are asked to submit full proposals. I have to say it wasn't wildly popular with the writing community, but it was pretty popular with the reviewing community, just because of the amount of work, which is often the same community, which is very interesting. It sets up sort of a bipolar problem in a person's head. But actually the issue I'd like to point out, which I think is equally serious, is of the 600 program officers at NSF, 300 are rotators, which means every year we're looking for 300 people to come in from the academic community to run programs. And so as that pool, it's been harder and harder and harder to get people in that pool. And that, in fact, is where you have a lot of influence over what a program is funding, over what the portfolio looks like, over how multidisciplinary the funds are going to be allocated. I mean, I would like to say to our interns who all want to do policy, that in the federal government, money is policy and policy is money. Every time you make a grant, you've created science policy because you've decided to fund one thing and not fund something else, which could have been equally meritorious. So it's the search for program officers and at higher levels, division directors, which has become harder and harder and harder. And I'm worried that we're not capturing the biggest thinkers in that process, because they're all out there like you are, right, trying to set up, Q3s and institutes and those kinds of things, and they're not coming to NSF. And so It can vary. It can vary a lot. I mean, we are human beings, right? And so we have a very difficult job of Yes, yes. It's really historical. It's really just historical. Well,
Yeah. Well, I think that's one of the kinds of recommendations maybe that can strongly be made as we think about coming out of this is when you're between a rock and a hard place and have to look for 300 people a year. As a academic dean looking for faculty on urgent basis, and that's only a few compared to the 300. I understand that.
I will say on the other side of the coin, we've also had people complain about permanent program officers, that they develop an affinity for the community. We call it drinking the Kool-Aid. And so you lose your objectivity to see new things coming because you're very vested in a certain pool of PIs. And so that's why this mixed model seems to introduce just enough disruption to the process that hopefully it resorts things, at least periodically.
Yeah, I think the key from this conversation about program officers is that we have to pay attention to keeping a fresh and vital, energetic set of program officers, whether they be transient or permanent in any agency, and that includes the private foundations, because we can all get lazy. And we could all be wrong, but if we're wrong consistently, we just have to be cautious. And I think a way of building a collegial set of program officers within an organization, within the NSF, within the NIH ranks, within the private foundations, is one way that we have an internal balance of checks and balances that go forward. One more comment on this section, and then I want to go to my colleague on the right.
Program directors, I think it's important that if you identify program directors who are not up to your expectations, we hear about it, because we can't do anything about it if we don't hear about it. And when I've been contacted, I've certainly followed up and hopefully rectified the problem.
Yeah.
Let me also just comment on review.
Very quickly, because I want to move on to the other question.
Okay. I think everyone agrees from both sides that there's a problem with review. I think the Center for Scientific Review is aware of it, beginning to try to address that. In the end, as Joe, I think you said, the problem goes back to the community. We have to have senior reviewers who are willing to take on that responsibility. At the same time, we are doing experiments with editorial board reviews across the NIH, which seem to be working quite well in terms of bringing in a larger cadre of people with different expertises who can contribute to the review.
Thank you. My colleague's been waiting there.
So I'm Jörg Lahand. So I'm here from the Biointerface Institute at the University of Michigan. Actually, Dave Kander yesterday talked a little bit about the Biointerface Institute. So I want to come back to John's question about the role of centers as nuclei for convergence research. And I would like to make 2 points here, actually. And one is, I think the physical proximity among interdisciplinary researchers is actually essential. Like at the Biointerface Institute, we really required all those 20 PIs from 4 different colleges to move out of the department and come all together in the same place the offices next to each other, so that they bump in each other, they talk with each other, they work with each other. I think that's really essential for the kind of things we want to see. The other point I want to make is, for me, convergence comes with an aim, with a goal. And aims and goals change. So I think what we have to think about, too, is how to basically reconfigure, how to build mechanisms into centers that allow us to reconfigure those centers as basically the aims and goals change. Like, I think the problem is not that we have centers, the problem is that we have centers and we believe the same type of center in the same configuration is going to continue forever. And I think we're going to have to think about building mechanisms that allow us to adjust that as basically the questions and the goals are changing. And I think this is one point that maybe we haven't looked much at yet.
So if I could just respond, I agree entirely with both those points. The first one about proximity is absolutely essential, although whether or not that requires a funding mechanism to achieve, I'm not sure, right? Because you could reorganize space within a university and put people together. And I'm being a gadfly here to some extent, you understand? The second question, remind me what it was again. I just blanked. Reconfiguring. Exactly. So ultimately, perhaps what you'd like to see is a center such as the one at University of Michigan become the university, right? I mean, in some ways, that might be the ultimate goal of convergence, that you don't need a group of individual centers focused on certain research problems in a convergent way, but that research, at least in scientific fields, maybe focused on biology, becomes how the universities do business. And maybe that's what we are looking for. On specific problems, sure. But the point was that those will change. Right, those will change, but maybe there need to be integrated mechanisms within universities for continually shifting those around and doing those things.
Yeah, I think the point is a point well taken, and I think that anything that can convene people, whether it be physical space, whether it be any kind of augmentation of programs, should be done, and that's really important. On the right there.
Again, Roderick Pettigrew from NIH. I want to comment on what I think is the biggest driver of convergence, and this somewhat ties in with funding models. It draws on comments made earlier by several people, Emily Brown and his comments, Manu and his comments, and then most recently Nick Pappas and his comments. And I would strongly agree that the most significant driver is solving a compelling big problem. Big problems are transdisciplinary by nature. Transdisciplinary problems require transdisciplinary solutions, and that stimulates this natural organic formation of convergent teams from which emerge new ways of thinking and approaching problems. The funding approaches that we've used at our institute, which incidentally was really created, mandated by Congress, based on the idea and the early concept of the interface of the physical engineering and life sciences, and we've been supporting that kind of research for about 11 years now. But we've used a couple of approaches, both explicit and implicit. The explicit approaches you've heard about somewhat from my colleagues, bioengineering research partnerships requiring collaborations between engineers and life sciences. But the one that I favor the most is the one that is more implicit, and that is challenging the community to solving a vexing major health care problem. One of the programs that we have that does that is we call it a quantum program.
Yeah.
And as the name suggests, the program challenges the community to identify high burden of disease problems that could be solved by some major innovation. And we try to support the teams that come together to solve these problems on a long-range basis. I could give you examples, but I hear the clock ticking in my head, and I won't go on and on and on. But I would tell you one of them, for example, is stroke. We have no way of treating stroke now. We have no way of really treating traumatic brain injury. When there is neuronal death and cell death, for a large part, that's it. So we have funded a transdisciplinary convergent team to try and engineer a complete neurovascular niche that could be implanted into the brain and eventually regrow and restore some function. So that is, I think, that kind of problem has brought together a number of disparate scientists, or scientists from a number of disciplines traditionally, in order to solve this vexing and challenging problem.
I agree, and and one thing that a term that gets sort of a dirty word, not necessarily in this room, but we'll say out on the street, is what you described as perfect. I could take that same term and I could say use-inspired research, there's some knees that buckle at that type of a term, but yeah, those are the exact types of things: a focused problem-solution research effort, a focused use-inspired research effort that would be handed off down the line, maybe to industry or maybe to venture capitalists, formation down. So I think we have to understand that there's some real essential and critical problems that are out there where convergent research, beyond only basic research, will have a really powerful avenue to making things happen. I'm going to ask Bill Harris, are you there? I'm going to ask Bill Harris from Science Foundation Arizona to say a couple of words, because the public-private partnership at the state level has come up in a few of our conversations here, and Bill is the president of Science Foundation Arizona. We heard about it earlier when we were talking about Arizona State, and it might be good just to understand this novel and important mechanism and how it works. So, Bill, just a couple of minutes.
Comment first. I'm actually the person who started the Science Technology Centers program at NSF years ago, and for about 10 years I was brutally criticized for being the person who undid the individual investigator grants. And that was never the intent. And it's actually amazing to see the evolution and the interest in centers and the important complementary roles they play. So this controversy is, it's really part of, I think, a bigger picture that we have allowed a system to grow since 1950 approximately, without any serious discussion or debate except give us more money. And it really would be helpful at some point for a serious discussion by the agencies and the scientific leadership of the academy to talk about where we are in the world today. It's an entirely different world, and we are operating kind of in, we hope, automatic pilot. But I think, as Joan and others have said clearly, the future is not going to be like the past. You've got to make hard choices. So going back to one more choice while I do your thing. When I was at NSF, one of the things I was trying to do as AD for MPS is to try to fix this issue of a physicist working in biology, or vice versa, a chemist working in physics, if you like. And we created something called an Office of Multidisciplinary Activities, which was meant to solve problems like that. And we were roundly criticized for that as well, because the program directors felt it was their money. So there are real systematic issues that could be addressed by really smart people and leadership. So let me use a Pogo quote and say we have met the enemy and he is us, or she is us. And let's not keep beating this same issue for the next 5 or 10 years and blaming the funders. They're not the enemy. We have created a monster that is an unintended consequence. And I think we're smart enough to figure out how to do something that would actually help science, help young scientists in particular, and help the future. So that's a suggestion. Now, Science Foundation Arizona, how did it come about? It came about because I went to Ireland for 5 years and started something called Science Foundation Ireland. They gave me, not gave me, they gave this organization $1 billion over 5 years, a country, or if you like, a state of 4 million people. That's a tremendous investment that the people made in their universities. And they could get money from the EU, but they felt at a local level they had to have some control of their destiny. And so when Janet Napolitano was the governor, she wanted to do something like that in Arizona through the business community. And the idea was, how can the state control its destiny better? It has all the federal money, but how can you leverage and be strategic at a state level, and then at the same time use the tool, if you like, or the entity, to educate better legislators about the importance of education and the workforce of the future. And if they don't have any responsibility, we felt at the state level, then they would never understand the issues. So they deferred them to the federal government for 50 years. And so I would think that at the state level, there's an important opportunity for the state legislators to begin to understand the importance of the work that you all do. Right now, in most states, it is a perfect vacuum, and there's pride in that perfect vacuum. There is no climate change. Evolution is nutty. You've heard all of the arguments. So the challenge that we had is, can you create an organization that would be a public-private partnership that would begin to address these issues in a serious way to complement Washington and leverage what Washington does? And for about 2.5 years, we were able to do it incredibly well. And then there was a transition, and when we transitioned government in the U.S. at the state and federal level, we flip-flop. We waste money, we waste time, and we waste ideas. And so Arizona did a flip-flop. And we had to be a bad idea because it was started by a person who happened to have a D by her name, but was supported by industry throughout the state. Colorado's had that problem. New Mexico tried to do the same thing. They changed the government to that problem. So we have a problem. We have to get involved. We have to be part of the solution and not just say, give us money. That's my challenge to you. And what we have done in Arizona is we have a really good board. It's a national board. We have decided that, okay, instead of waiting for the state to come back to the table, we will work on developing national philanthropic money in the public interest. And we have been hugely successful. At least we have a lot of commitments. The money has about started to come rolling around beyond me. But we have a huge interest by national philanthropists because they are as frustrated as this community is in here about the state of the country from the point of view of economic competitiveness, and they're worrying about the possible leadership decay of the scientific community relative to the world. So I think, Jim, we have big challenges. I think states getting involved in some way with something like what we do is an important thing. Eric Block and I have just written a paper that we're going to publish on this stuff. But the real challenge, I think, is to get the state legislators involved so there's buy-in for the competitive situation that the country has today. I think without that, I don't think Washington, D.C. can do it by itself. And I don't think NSF or NICE can do it by themselves. They need new partners. And the federal government is likely to be highly constrained financially. There is a huge possibility, you could imagine models where states begin to get into this thing. You could get significantly new money into the table. And they would be interested in the idea of convergence. They'd be interested in the idea of a new way to educate people. And they'd be very interested in the fact that you might actually create the possibility of new companies and jobs for the future. So I think the future, Jim, is going to be new partnerships, but I think it can't just be blaming the feds.
I agree, Bill. Thank you. I'm going to bring this session to a close, but I'm not going to bring the conversation to a close because this is a very, very important conversation. It should occur amongst all of you, with one another, and with your colleagues back on campuses. But the one thing that I heard, and I think Bill summarized it very well, is there are multiple routes to getting our job accomplished, multiple routes to solving our problem. They begin at home, on our home campuses, and they can then extend to support from a variety of agencies. And I want to add, Bill, you don't know this, but I've actually signed a contract with a city now in the model of Science Foundation Arizona. So the city where we live is now going to be funding some things at our institution because I was able to show we are an economic value added to living in that town. So with that, I want to thank the panelists. I want to thank the committee for putting this